Hey, in this presentation, we're going to demonstrate our project, Smart Home Systems, using a Raspberry Pi. We live in the information era, where data is the most valuable asset in the world. We believe that the main value we will provide to our customers is information. Our main motivation is the need of remote home monitoring. Having an eye on the user's home while they're absent would definitely make the user feel safer and will allow them to be confident that everything is okay back home while they're away. However, security is a big concern when it comes to a private data like that. So we want to make sure that there is at least some restrictions about accessing these private data of the customers. Moving on to the next slide. The approach we are implementing is formed by four main components. First, multiple sensors to read and provide the data. Second, a control unit that manages and processes the data from the sensor modules. Third, a RESTful API that makes the data available and an instant notification feature that will allow the user to be warned when certain levels are read by the sensors.
In this design diagram, we can see the interconnection and relationship between all the major components of our system. At the center, we can see the control unit where the data is stored, managed, and where all the main features are implemented. Via the Bluetooth Low Energy Wireless Communication Protocol, the control unit will receive the sensor readings from the sensor modules every 5 seconds. Then, in order to make the data available through the internet, we will be implementing a RESTful API that, while maintaining the data is safe, it will allow users to access the systems from outside the house via mobile apps, web interface, or any platforms that supports HTTPS requests. Some of the main features of our system include data over time. Data over time will provide not only current data, but it will allow users to store old data as well as to facilitate statistical analysis. Personalized user account. User accounts for security and personalization process, since multiple tenants may need to have different privileges to data. Instant notifications. With the user account, personalized instant notifications can be also provided. Cross-platform access through the RESTful API. The most important feature will be the accessibility provided by the RESTful API that will allow users to interact with the system from different platforms, from their mobile phones to their web browser.
The main components of our smart home system are the control unit and the sensor modules. For the system's control unit, we decided to use a Raspberry Pi since it's easy to set up and includes many desired features like Wi-Fi for internet connectivity, Bluetooth, and an actual operating system that simplifies the addition of a touchscreen display and the programming in general. Plus, it's extremely well documented in the engineering community and there's a lot of support out there. For the sensor modules, we decided to go with the Arduino Nano board just because they're low power and capable of communicating to multiple sensors and serial devices, including the communication module. Another big advantage that played an important role in this decision was the size of the board, since it will allow us to have more freedom in the physical design, considering even the addition of a battery instead of a power cord that would limit users when placing them around the house. One of the big decisions during the design process was the selection of the wireless communication protocol. After considering Bluetooth, RF, Zigbee, and Wi-Fi, we decided to use BLE, which stands for Bluetooth Low Energy, mainly because of the range, power consumption, and compatibility. For the sensors, we selected cheap and easy to use sensors that provided us with useful data while being also reliable. Another important decision we made was to use throughout our project object-oriented programming principles and decoupling functionalities as much as we can. This will allow us to easily replace or even add more technologies if we had to, while making minimal changes to the code, making our team even more agile. Now, going into the results section, during this semester, we were able to complete the majority of the hardware-related work of our project. We successfully connected one of the sensor modules to the control unit and displayed real-time data using a basic GUI. In this image, you can see our current product. You see on the top, we have the air quality sensor, we have the temperature and humidity sensor here, we have the Bluetooth module. And for troubleshooting purposes, we use the Arduino Uno instead of the Nano. And the reason why is because we wanted to troubleshoot using the serial monitor on the computer. And if we use the Arduino Nano, we could not do that because it only has one serial port, and we needed one to communicate with the Bluetooth. So the code will be completely transferable to the Arduino Nano, so we don't see any problems in that area. At the bottom here, you can see the 3.5-inch screen with the basic GUI that allowed us to confirm the communication between these two devices. Next, I'll show a short video where you can see the basic functionality of the GUI. As you can see, we have a pretty basic layout here where we need to scan the modules, and then we need to select from a list of all the devices connected or detected by the Raspberry Pi. Once we select the right MAC address, then we connect and we can see the real values of the sensors being read from the sensor modules.
Here are the values that we will provide at the end of the project. First, providing live data to the customers to keep them updated of the environment inside their homes. Second, an easy-to-use and self-explanatory graphical user interface that displays real-time data and allows them to personalize the interaction and the experience. And finally, alerts. Notifying and alerting the customer in case of odd changes in the data inside their home is one of the most important value we will create in this project. For instance, if the air quality sensor detected a poor value in the home, the system will immediately send an alert to the customer notifying them of the odd values detected. This feature can be customized by the user, in which they can manually set parameters for the data they think is abnormal.
During this past 3 months, and while working on the smart home system using the Raspberry Pi project, all the three of us have learned an important lessons in the technical fields and in the dealing with people field also. The first lesson we have learned from the beginning of the 2 week, that we need to know how to manage our time and having everything done on its right time. The most important thing is communication, a team communication, which we faced a problem with it, but we could solve it and learned the lesson from that situation. Some of us have learned a new programming skills like Python because we did not do this language during our studying years, but we find out that it will help making our works easier. The important thing we should always keep in mind is also a context, because sometimes it is easier for us to develop a code on Windows or a Mac, but at the same time we should make sure that it will work with the Raspbian operating system we are using with the Raspberry Pi unit. Our research skills has been developing throughout the semester, since every time we face something, we have to search for the specific thing, which required from us to reduce our search circle and look for very detailed information we needed. The last important skill we learned is project management techniques, more specifically Agile development, since we were part of a Scrum team and we witnessed the importance of short iterations that allow us to quickly adapt to changes and deliver working software quicker.
Looking into the future, we still have the most difficult part of the project ahead of us. First, we'll need to learn how to build our own RESTful API and make our data accessible through the internet. In order to test this feature, we'll need to develop either a web interface or a mobile app. Since we'll be dealing with data about our users' home, we'll build in some security features into the REST API so the users can control visibility, permissions, etc. Finally, to make the system even more interesting and valuable, we want to add instant notifications that the user can configure easily through the control unit or the RESTful API. Thanks a lot.